So here is the video on hybrid parameter. So hybrid parameter is actually a combination of impedance and admittance parameter. Since as we know, for impedance parameter, we normally take voltage V1 and V2 as the dependent variables, and for admittance parameter we take I2 and I1 as the dependent variables. So for hybrid parameter, we combine both of voltage and current as a dependent variables. So again, we have this kind of equation where you need to find what is the parameter for H11, H12, and H21 and H22. So basically, similarly as what in admittance and in impedance parameter, so these two value is the network is reciprocal if H12 is equal to negative of H21. So for hybrid parameter, we have only one way to solve, which is we have to implement method 1, where we set the independent variables as 0 to calculate what is the H parameters. So basically, first step, we need to set I1 as 0 to calculate what is H12 and H22. So basically, H12, when we set 0 at I1, so H11 and H21 will be 0, and then therefore we can calculate H12 and H22. So H12 is equal to V1 over V2, since we take voltage divided by voltage, so there will be no units here. And for H22 is equal to I2 divided by V2. So for this case, this one is actually similar to admittance. So the unit should be S or mho, or ohms, inverse of ohms. And when we set V2 equal to 0, so basically we don't have this, and we can calculate what is H11 and H21. So again, H11 is equal to V1 over I1, and the unit should be equal to impedance, which is ohms, in ohm. And then for H21 is equal to I2 divided by I1. So there will be no units for this parameter. So again, similarly as what we had done for impedance and admittance parameter, where for voltage we set as 0. When we set voltage as 0, so the voltage is actually being short circuit, while for current, when we set I equal to 0, so I is open circuit. So this is case when we get the H parameter equivalent network for non-reciprocal network. So for reciprocal network, you have to solve using the method 1 only. So similarly for inverse hybrid, it's actually similar with in the normal hybrid. It's just that for inverse hybrid, we set the dependent value will be I1 and V2 instead of V1 and I2. So the parameter for inverse hybrid will be labeled as G. So the same concept apply for inverse hybrid. Moving forward to the first example, where the given problem is as illustrated here, and we need to determine what is the hybrid parameter for this two-port network. Okay, so for this side, the dependence variable should be current, so we label as I1, and we need to obtain what is V1 here. And for this side will be voltage V2, and we need to obtain what is current at this branch, which is I2. So first step, we need to set we can either set I1 as 0 or V2 as 0 first. So let's set V2 as 0. So when we set V2 as 0, so this line will be short circuit, and we need to calculate what is current at this branch, which is I2. So when we set V2 as 0, so automatically this part will be equal to 0. Then from that we can calculate H11 equal to H11 multiplied with I1 plus with H12 multiplied with 0 equal to V1. So this part will be 0. So basically H11 is equal to V1 divided by I1. Similarly for this row, so I1 will be I1 multiplied with H21 plus with 0 multiplied with H22. This one will be 0 equal to I2. So H21 is equal to I2 divided by I1. Okay. So basically for both parameter we have I1. So we need to find V1 and I2 in terms of I1 to calculate what is H11. So to calculate V1 in terms of I1, so V1 is here and I1 is here. So we need to calculate what is the total Z at this circuit to calculate what is V1 in terms of I1. So for this case, the Z total will be from this side. So 3 will be parallel with 6 and then plus with 2. 3 parallel with 6 plus with 2. So 3 parallel with 6 we will get 2 and then plus with 2. So the answer will be 4 ohm. So next, to calculate voltage V1, so we have the total impedance and we have current I1. So V, according to Ohm's law, V1 is equal to I1 multiplied with Z total. So Z total will be 4 I1. Okay. So next, to calculate I2 in terms of I1 to get H21, we can actually use current divider rules, CDR, to calculate current flow at this branch. But I2 will be the opposite value of current flow here. So by using CDR, we can actually ignore this resistor, since we already know current that flow to 2 ohm resistor. So we can directly use this current to calculate what is current flow at this branch. So according to CDR, so IA is equal to the opposite impedance, the opposite resistor divided by the total of these two impedance. So 3 plus with 6 multiply with the current source, so I1. So we get 6 over 9 I1. So basically I2 is inverse of IA. So I2 is equal to negative IA sorry, not inverse, is should be negative of current, because it flow in different direction. So once we get what is V1 and I2, then we can directly calculate what is H11 and H21. So H11 is equal to V1 divided by I1. So for this case, V1 is 4I1 divided by I1. Then we get 4. So the unit should be V1 over I is ohm. Okay, so for H21, I2 divided by I1. So I2 is equal to negative 6 over 9 I1 divided by I1. So basically H21 is equal to 6 over 9. So we can actually reduce this to get 2 over 3, negative 2 over 3. So this one no unit, since I current divided by current. So next, set I1 as 0 means that we need to open circuit this part, and we need to calculate what is V1 and also I2 in terms of V2. So from that we can actually calculate, get the H21 and H22 parameter. So H12 is equal to H12 for this case is equal to V1 divided by V2, and H22 is equal to I2 divided by V2. Okay, so both parameter we have V2, then we need to find what is V1 and I2 in terms of V2. So to get V1 here, obviously when there is open circuit at this part, so the current will not flow to this resistor, so we can ignore this. So basically V1 is actually at 6 ohm. Then we can apply VDR, voltage divider rules. So V1 is equal to, we need to take this resistor divided by the total of these two resistors. So 6 divided by 6 plus 3 multiply with V2. So we get 6 over 9 V2. So we can simplify this to, and we get 2 over 3 V2. So next step, we need to calculate what is I2 in terms of V2. So basically we don't have this resistor, since this is open circuit, so current flow from the source will not go through this, will not pass through this branch, so it will directly flow here to here. So I2 will be equal to Ohm's law. Using Ohm's law, V over Z total. So for V for this case is V2 divided by Z total, will be 3 plus with 6, since these two resistor is in series. So we get 9. Yep. So next, to calculate H21 equal to V1 divided by V2. So V1 is equal to 2 over 3 V2. So basically 2 over 3 V2 divided by V2. Then we get 2 over 3. So for H12 we don't have units here because voltage divided by dot voltage. Then next for H22, I2 divided by V2. So I2 is equal to V2 divided by 9. Then we divide with V2. So we get 1 over 9. And the unit will be more, or S for this case. Then we need to rearrange all these values in matrix form. So H11 is equal to 4. H21 is equal to negative 2 over 3. H12 is 2 over 3. And next, H22 is 1 over 9. So we can conclude that this network is reciprocal, since H12 is a negative H21. Okay, for example 2, we have an dependent source here. So similarly, we need to, as what we done in the previous example, we need to put current source here and voltage source at here. So first step, set V2 as 0, and again, so when we set V2 as 0, this line will be short circuit. So this is the circuit after we short this area. Then we need to calculate H11 and H21. Okay, since this circuit consists of 3 loops, so we need to solve it using nodal mesh or any AC circuit theorem that you prefer. So for this case, it's convenient to use nodal because we have, for nodal we only involve 2 equations since we have 2 nodes. If you use mesh, you will have you can also use mesh, because even though it consists 3 loops, so basically you need to calculate three things. But for the first loop, we can actually take this as we can actually get this value already. So I prefer to use nodal. So we set this node as V1 and VA and VB. Otherwise you will get confused with V1, since V1 is should be here. So to generate equation from here, so basically nodal, it use KCL concept, where we total up the current flow out from this node equal to 0. So VA divide so current flow here plus current flow at this branch plus current flow at this branch is equal to 0. So for this case, this current will be negative of this, negative I1. So we don't have to find what is current flow here, since we already know current source here should be equal to current flow at this branch. Plus with VA divided by 2 ohm, plus with VA minus VB divided by 3 equal to 0. So basically we need to rearrange this equation, find what is VA, or parameter for VA, and then next for VB equal to value. So for this case, VA is, we have 1 over 2 plus with 1 over 3, and for VB we have negative 1 over 3. Okay, so this part we will get 6, 2 plus with 5, 3, so 5 over 6 VA minus 1 over 3 VB equal to I1. So this is our first equation. So next, for the second node, node VB, we have VB minus VA over 3 for this branch we already have the current here, so the dependent current here, so it should be negative 4I1 plus with VB over 2 equal to 0. So for this case, I1 is actually referred to current flow at this branch, so we already labeled as this also as I1. So we rearrange again, we rearrange this equation, and we get 1 over 3 VA plus with 1 over 3 plus with 1 over 2. Again we get 5 over 6 VB equal to 4 I1. So this is our second equation. Then we need to rearrange these two equations in matrix form. So 5 over 6, negative 1 over 3, and negative 1 over 3, and we have 5 over 6 again. So VA over VB equal to I1 and 4 I1. So to solve this, to calculate VA and VB, you can use Cramer rules or any or other method like simultaneous equation. So after apply Cramer rules, so I got VA as negative 26 over 7 I1 and VB is 44 over 7 I1. So basically we need to calculate what is V1 here. So we can actually, and also and also I2 here. So we need VA and both VA and VB. Okay, so for this case, to get so since we already calculate what is VA here, so we can actually automatically remove this part and include the source VA here. Okay, so actually V1 is voltage measured at this source, so we can remove this current source and replace with V1 here, and then we have 4 and VA. Okay, it's actually this part. So we know that the current flow at this loop is I1, which is from the source. So automatically we can use we can actually apply KVL, Kirchhoff voltage law. So negative V1 plus with this voltage and this voltage is equal to 0. So this voltage is equal to 4 multiplied with I1 plus with VA equal to 0. Then we can calculate V1 equal to 4 I1 plus VA is negative 26 over 7 I1. Then we got 2 over 7 I1. Okay, so next to calculate I2 here, since we already get VB, so VB is voltage measure here and also voltage drop at this part. Since these two is actually parallel, so the voltage should be equal to this node. So we already know voltage at drop at this 2 ohm resistor is equal to VB, and we can calculate what is I2. So the direction, since the current direction should be this, should be here. So VB is equal to negative 2I2, negative 2I2. Okay, so I2 is equal to negative VB over 2. So negative VB is 44 over 7 divided by 2. So the answer will be negative 22 over 7. Okay, so once you get the value for V1, oh, I forgot to put I1 here. So VB is actually 44 over 7 I1. So here should be I1. Okay, and we can calculate what is H11. H11 is referred to V1 over I1. So we already calculate V1 here, which is equal to 2 over 7 divided with I1, so you get 2 over 7 here. So the unit should be in ohm. And then for H21 is I2 divided by I1. So I2 is negative 22 over 7 divided by I1. So these two can cancel out. So we get negative 22 over 7. So this one no unit. So next, we set I1 as 0. So it will be open circuit at this part. Okay. Then we can calculate H12. H12 equal to V1 divided by V2, and then H22 equal to I2 divided by V2. Okay. So we have dependent source here. So this current source actually dependent on current flow at this branch. Since I1 is 0, so automatically this dependent source will become 0. So we don't have to consider this part. So your circuit will be reduced, will become like this. Okay, so again, voltage measured at this part is actually voltage at this 2 ohm. Since current from this source will not flow to this branch, so there will be no voltage drop here. So automatically voltage at this open circuit will be equal to voltage drop at this resistor. So to calculate what is H12 and H22, you can simply use basic laws like Ohm's law, KVL, KCL, or CDR or VDR. Okay, so basically we need to calculate what is V1 and I2 in terms of V2. So to calculate what is V1 is actually voltage drop at 2 ohm. So you can actually use voltage divider rules. Since we already know this voltage here is equal to V2, so we can apply directly. Voltage V1 is equal to 2 divided by the total of impedance. So 2 plus 3 plus 2, which is equal to 7 V2. Okay. Then next, for I2, current flow at this branch, this loop. So since the current will not flow to this resistor, so basically all resistor at this part is actually in series connection. So since current will flow directly from here to here and back to source. Okay, so we can directly use Ohm's law, which is equal to V2 divided by Z total. So Z total for this case again is equal to 7. Then you can substitute in here. So H12 is equal to 2 over 7 and for H22 is equal to 1/7. So the unit for H12 will be no unit, and for H22 is more. So again rearrange in matrix form. Okay, so H11 is equal to 2/7, H21 is negative 22/7, and H12 is equal to 2/7, and next H22 is 1/7. So for this case, this is non-reciprocal case, since H12 is not equal to negative H21, since these two values are different.